how good dryer is the AMS2 Pro compared to other dedicated dryers. Welcome to my tech farm. In this video, I want to test the drying capabilities of Bambu Lab AMS2 Pro unit. If you are not familiar, it can be used as a filament dryer, and I tested on this channel at least 20 filament dryers. And I have my regular testing method, that's sponge drying test, and I'm measuring the temperature and relative humidity during that 1 hour, and then I'm analyzing these numbers. And I want to repeat this test with the AMS2 Pro unit too. This video is not sponsored by Bambu Lab. I got this unit for the review of the printer, but this video is still sponsored, and actually the whole channel, by Polymaker, who likes to support my research activity. Let's see a few overall specifications from the website. Active air vent and the maximal temperature is 65 degrees Celsius, and this means that from time to time it can open the ventilation on the backside and let out the moisture. This is important because I tested some filament dryers where I could measure that the moisture stuck inside. Airtight filament storage, this means that we even have some desiccants, and when we finish the drying we can store the filament and it will keep that dry environment around it. Brushless motors for faster feeding, ceramic inlet, open bottom to access Teflon tubes. If we have some break inside, then we have to open it, and it's easier to do it on the AMS2 Pro compared to earlier versions. And now, very important property, it can do auto rotating during the drying. Of course, for this the filament cannot be plugged. Earlier we cannot even start the drying if the filament is plugged, so we have to unplug it, and we can enable the rotating of the spool if necessary. This is very important for more even drying of the filament. Now, after latest firmware update, we can actually start the drying even if the filament is plugged, and we can even start the printing during the drying, only it will reduce the temperatures to avoid too big softening of the filament during the printing. But this is not what I'm testing. I'm testing using this AMS2 Pro as a filament dryer. And to prevent those comments which will ask if I will test the high temperature AMS, well, actually the comments are good for the video, so I'm working against myself. Yes, I will test the HT AMS, and I already have it here. It was sent by the Bambu Lab exactly for this purpose, to measure its drying capabilities. I removed the plug on the back side so I can enter the wires, and I used some Kapton tape to seal the hole because I don't want any heat to escape. I used DHT22 humidity and temperature sensor, and the position of the sensor is approximately 50 or 60 millimeters above the entering hot air. I inserted two spools just to reduce a little bit the volume of the air which has to be heated up. This is what I usually do with this size of the dryers. And the position of the sponge will be approximately in the center of the spools. The values are collected with Arduino Uno, and the current temperature and relative humidity I can see on the screen, but also the laptop is collecting the data every 10 seconds. Weight of the empty sponge 0.563 grams. Adding 2 milliliters of water, 2.609, but I'm measuring the weight, it's more accurate compared to the volume. The maximum is 65 degrees Celsius, I will set the ABS. No need to rotate the spool. The next measuring will be in half hours. I'm collecting the data, and the current temperature is approximately 33 degrees Celsius, but we will analyze the graph at the end. Only after 25 minutes it reached 50 degrees Celsius, and relative humidity is still quite high, 39%, so that ventilation should work a little bit better, I think. Soon it will be time for half-hour measuring. I'm not too happy with the temperatures. I think I'm measuring quite close to the hot air, but later I will measure directly the hottest air which comes in. Time for the half-hour measuring. 1.544. Still quite wet. Now I heard that it opened the ventilation doors. We will see later on the graph if there is any result. After 15 minutes, the temperature inside only 55 degrees Celsius and relative humidity 26. But let's check what can we see through the thermal camera. The front side, the hottest 46 degrees Celsius. The back side, hottest on the lid, 51 degrees Celsius. I think it's visible that the hot air comes on the back side here, which means that the sensor is very close to the input hot air, which is still only 56 degrees Celsius. 4 more minutes before the last measuring, and according to its own sensor, the temperature inside is 65 degrees Celsius and relative humidity 26%. According to my sensors, 56 and 25 the relative humidity. Time for the last measuring. 0.591. Actually, for the feeling, it's quite dry, but not completely. And I will not stop the drying here, because I can still see that the temperature is rising, and I'm very curious when will it stabilize. I couldn't record any changes in the last 5 minutes, and the peak is approximately 59 degrees Celsius, which is close enough, and relative humidity 18%. The drying is still in progress, but I want to move the sensor to be exactly above the hot air. It's stabilized now. I'm measuring 64.7 degrees Celsius. This means the set temperature is correct, and that's the temperature of the input hot air. So the heating up is a little bit slow, but the maximal temperature is actually the temperature of the input hot air. And that's fine if you enable the rotating of the spool, that's very important. Only thing I don't like here is the 17% relative humidity. On my sensor it is 14. I think those ventilation waves could work a little bit more often. I can hear them only 2 or 3 times during these 1.5 hours, or maybe below 20%, they don't even enable, I'm not really sure. In that case, that's fine. Maybe higher relative humidity is also a result of the wet desiccant, which was stored in almost 50% relative humidity. Last time it was dried maybe a few months ago. Another reason is the position of the valve in the corner, so only part of the circulating air can benefit from it. Let's analyze the measured data. This is the time in minutes, and here we can see the temperature and relative humidity. Let's start with the temperature. Here it was open for 30-minute measuring, and here for 1 hour measuring, and I continued with the drying because I was curious when will it stabilize. And after 1.5 hours it reached its maximum, which was 59 degrees Celsius, but the sensor was approximately 50 millimeters above the input hot air. If this would be some PTC heater, which rely on the rotating of the air only, I would say that this is not enough. But since the very important property of the AMS2 Pro is rotating of the spool, in this case the temperature of the input hot air is more important. I measured this, we will discuss it later on the graph, so I would say this works correctly. Let's talk about relative humidity. It was quite high, and here when I open it for the 30-minute measuring, I let out quite a lot of moisture. And similar thing here after 60 minutes. I recorded one ventilation opening here at 43 minutes. We can see some very small break here, but hardly noticeable. This means these ventilation waves don't really work correctly. They open properly, but there is nothing to push out that moist air. I think this would require some better solution, maybe with some fan or something like that, I'm not sure. This dryer has a similar solution, and here we can clearly see the reduction in relative humidity. About the sponge drying test, after 30 minutes it removed 52% of the water, and after 1 hour 99%, which is noticeably weaker compared to those 70-degree dryers which I tested so far, and I've never tested the 65-degree version so far, so I don't really have other numbers for the comparison, but I think this is acceptable for this temperature. On this graph we can see the temperature of the input hot air when the sensor was exactly above the opening for this air, and very quickly it reached its maximum of 64.7 degrees Celsius, which was very close to the set temperature of 65. And here it was turned off, and this is the cooling data. Final thoughts. Well, the heating up is a little bit slow, but it will reach that set temperature, which is the temperature of the input hot air. And in this case, this is enough because very important property of the AMS2 Pro is possibility of rotating the spools during the drying. And also don't forget that it must heat up the space for 4 spools, because usually I tested some smaller dryers, maximum with the 2 spools volume or something like that. This means it is enough for the PLA, PETG, TPU, maybe even ABS, but ABS is not so sensitive to moisture. If you want to dry nylon, polycarbonate, PPA, PPS, in that case we need high temperatures, at least 85 degrees Celsius, and that's why I will test soon the HT AMS, which is already here, but the video will be published in probably, I don't know, 2 or 3 weeks. And I hope you will follow me to that video too. Huge thanks to the Polymaker for sponsoring my channel, and to all my Patreon supporters, and to all you others. Thank you for watching this video till the end, and as always, happy drying and printing.